Welcome. Now we're going to look at the modeling of a shaft with two keyholes in there, keyways. As you recall, as we were going through and talking about keys, we said that if you had the key was too long for just one, too much force for just one key, that you could put a second key in, if the key would be too long, and to do that at 90 degrees. And the question arose is whether that there's a benefit from a stress standpoint of having it 90 degrees versus 180 degrees. So in this assignment, you're going to compare those two. So this model, I have the 90-degree keyways in there. And you can see I've kind of had a ramp out, and there is some typical, I didn't pay real close attention to the geometry. So hopefully it's not too critical here. This is a chance using FEA to get analysis and to focus on some of the mesh. Now, if we come back to my project screen, you can come in, I've already done a few steps here. You can come and import, if you right click on here, you won't see it because I've already done it, but when you right click a new one, you have an option of importing geometry. I could also replace the geometry here, which would be a similar step. We could go ahead and use a default steel material for this. Because we're doing linear elastic analysis, we're comparing two geometries. The specific material properties are not critical to this the question we need to answer. I have created two static structural analyses, and you'll notice there's no connection between these because I'm going to use different geometries. But that allows me to keep both models in the same location, which to me is helpful, so I don't have to try to remember they're the same files and so on, and I can compare them more readily. So let's go back to mechanical, and I've got to do two things. I need to apply a torque on here because that's the point of a key, and typically whatever we're mounting on the key in many cases will have a force on it, and so we want to include both of those effects in this model. But I'm going to suggest that we will do that by putting a force on these keyways on the surface, which I think is important because we need to put a force on one and a torque on the other. If I were to fix these faces, that may be less physical than putting a pressure on them. Now, another alternative is to create a key that we would press up against that. And that would be better analysis. But then we need to do contact, and we're going to do that on the next problem set. So we'll just take a little simpler approach here and see what kind of answer we get. So I'm going to start by fixing this larger face. So we can come in here, apply our supports. And I'm just going to apply a fixed support there. That's not entirely physical, but it's a way for the area of interest, and so it shouldn't apply. It's a good, quick solution. Now, with that, I need to apply forces to create a bending moment and the torque. For the bending moment, I could put a load here in the middle, transverse to this, but I don't have the length of the shaft to get the full bending moment. So I'm going to go ahead and apply a moment, and I'll apply it on this opposite face. So it'll get a constant moment across there, which should be good. Now, let's see, so I'll apply the geometry, and let's do this with components. Now, the question is going to be, what bending axis do I want to bend this around? And the question may be, which is most severe? And I'm going to leave you to think about that or to try a couple. But for this simulation, I'm going to go ahead and bend it around the X, put a moment around the X axis. You can, I just chose 20 inch-pounds. The ratio of the torque a moment may matter a little bit, but again, we're comparing two geometries with the same load. So the specific stress or specific values are not as important. But we're just illustrating the process, and I'll put instructions online as what values to use. So let's go with 20 inch-pounds there. And now I need to represent the force that's going to be applied by the key. Now, the key would stop short of this ramp, but for ease, we're not going to split the face. I'll just select that whole face, and I'll put a pressure on it, and apply. And I'm going to put a force because it's a little easier to calculate. And so the magnitude of that force, let's do 50 pounds. And I'm going to use the vector. So the direction, it's automatically selecting normal, although I need to switch the direction. So let's see. So you can select a vector by getting an edge, and so that's what I've done here, and I can see it's pointing in the right direction, so I'll hit apply, and that's good. Now I need to go do that again, force, and I want to put this on there. Now obviously we want to choose them so they're both going to tend to rotate the shaft the same direction. Now there would be some question in practice. They wouldn't necessarily be loaded equally, but you know that's still a good a starting assumption for this. Okay, so let's get our direction, apply that, and we see we've got our forces applied to this. Right now, I have one of the things I could do if I want to look at some different values of this. Maybe I'm going to define 4 analysis steps, and now I can come back in with the moment, and I can have that moment be 0 in the first one, and then 25, 50, and then we can take our forces, and we'll have those you see it wants to, often these are used to interpolate, so that's why it starts out to that. So I have a moment, I'll look at it with ramping moments, and then I'll have a moment with no force at the end. So first, let's go ahead and drop that. Yeah, so we've got 0 moment, and then ramping that up, and then I have force with those higher moments followed by no force. I could just get the moment alone in the last state. You know, just one way of looking at different loading conditions. You could similarly, if you wanted to check moments about different axes, you could apply a similar criteria. All right, so I have these defined, but I need to define my mesh. Let's go ahead and just create a general mesh for starters. Okay. So you can see I've got these fillets in here, and there's smaller elements there, but it's hard to see just how small they are. And so one of the things that we can do is create a cross section so that we're able to see what's happening inside, and really be able to see the size of those elements. In order to be able to create those sections, we'll come down to View, Windows, and I can do Section Planes. You notice that opens a new view down here. And it looks like I have a couple defined, but let's show you how they work. So I can create new section plane, and I just come over here, and this is one of those things that's kind of eyeballed. So one way I may want to look at is vertically. So now I created a section plane there, and I can rotate my view and see the size of those elements. Now sometimes it's a little deceptive because, I mean, in general I can see that it coarsens really rapidly, and that's not good enough in this case. But it's hard to see if you're just sectioning a little corner of an element or what the whole element is. And so you can turn on this function, which kind of selects whole elements. And then we select the section plane. I can say edit section plane, and I get this cursor, I can drive it along. And so you can see that there's a fine tip to those elements, but they really aren't, I don't have a small element. They tend to be fairly large relative to the radius, and there's not ongoing refinement down into the mesh. Okay, so I can see that I need a better mesh. Now you can also see that these are tetrahedral elements, little pyramids, which are easier to mesh, but are to create an automated mesh for, but they don't yield as much accuracy as quickly, and so you need finer elements. So now back in this area, even there, that's probably a little coarser than I may want for some of those. Let's drag this along and see. Yeah, I mean it's a little bit coarse on the inside. So let's come in and look at the sizing of my mesh. So I'll just adjust that, and I can update it to see what that does. Okay, so that obviously coarsened it. That's not what we want to do. So let's come back, element size up. So it's defaulted to 1 inch. So let's So you're going to try some of these different things and get some of the general mesh you want, and you can do that right there from the sizing process. And let's edit our section plane again, so we can drag this back and forth. So I'm getting a finer mesh on the surface, fairly coarse in the middle. I don't care a lot about that region, but I'd feel a little more comfortable with a bit finer mesh. So let's come in and put some mesh control. Let's do a sizing control, and just to be clear, I'll just start by sizing the overall body. And so that default line is 0.18. Let's put that down about 0.125. Okay. And then that's not going to be nearly good enough in these fillets. I should make that 0.1. So let's go ahead and create, oh, sorry, I need to apply my solid there. Okay, so let me come in and create a new mesh control. And again, let's do sizing. And let me turn off my section plane so I can see the whole geometry. And now I want to select a surface. So I expect my peaks are going to be, one of my peak areas is going to be around these, where the force is applied, and in these fillets. So let me just hold down the control key and select a few of those. Oops, that's not the side that the stress is applied on. So let's switch over to here. Yeah, so that's the right force. And so let me come back there, face sizing. So I need to pick a size, and I'm going to say 0.0. The fillet is radius 0.02. Let's see what 0.01 looks like. And okay, and then I'm going to want to do that again for well, let's go ahead and mesh that and see what it looks like before we install all of those. So update the mesh. So my mesh is updated. I'll hit show mesh. You can certainly see a lot of fine elements in there. It looks like it's only one element deep. And you can see these are some high aspect ratio elements in and around that region, which is concerning. And there are a few things I might try. One, I might make this more softer adjustment, which may give it a little bit more flexibility. It's also helpful if I adjust this inflation, and I want to have this grow much more slowly. Okay. These are some things I haven't used before in some of this inflation option in the transition ratios. I think making that bigger and growth rate smaller, closer to 1, will both help improve the quality of that mesh. So I'm going to rerun that and see how that looks. I think I also want to select some of these adjacent faces and just create a little bit, another mesh control, another face sizing in here, just to help provide a little bit more of a transition between the really refined regions and the others. So let's get selected geometry, and let's pick 0.0. At 0.05 and update and see how that works. Okay, so I've done two different things here. One, the last time we looked at this one where we set a size on these faces, and you can see that it's really fine on that face, but it transitions away really quickly. The other one, I selected an intermediate size on all of these faces in here of around I think 0.05, and then I created a refinement feature and selected just these faces around here in the fillets and set that at level 3 refinement, which you can see gives a broader transition. And then on this fillet over here, I just selected the refinement on the fillet, and again a level 3. So let's take a look at what that looks like in these section planes. Okay, so I can see that I'm transitioning out here in 3, 4, maybe 5 layers in some cases, whereas here I'm transitioning in size all in 1 layer. And so I'm liking what that refinement did for me a lot more. Let's see what it looks like. Okay, so now I've selected a different section plane, that section crosslink. I can also see what's happening here. And again, we see that the transition is happening over 4 more element planes. So that's looking a lot better in way of doing the refinement in this case. So we will go ahead and we can define some plots. I guess we have some defined there. So let's go ahead and solve this and take a look at the stresses. Okay, so now we have solved the model. You recall that I set this up in multiple load steps, so you don't have to. But we can, here we have both a bending moment and the forces for the torque and the keys applied to it. And you can see stresses top and bottom. So this is von Mises, equivalent stress. So the sign comes out positive for both tensile and compressive stresses. But you can see that there is peaks at the top and bottom, as you would expect for a bending load. So where the bending stress is at extremes, we also see peaks in that fillet. And then we see some peaks along the corners in the where the fillet is. So your question is, is this, first of all, are these a good representation? Is that adequate stress state? is it the right orientation of the moment, where the stresses from the moment are going to add to the stresses from in the fillet versus subtract from it, or not have any there, as the case may be. And then compare the two geometries. So one of the things that will be helpful to you is to come and use a section plane so you can see what some of these stresses are below the surface. And you can see the difference between this one. I have a poor mesh, this one I have a better mesh. I'm going to turn off the whole elements so it smooths and interpolates that. Helps a little bit with the comparisons there. So let's see. So let's see kind of where those stresses are, and they're a little different. Yeah, with the different meshes, it's hard to say whether they're to make a meaningful comparison between the two sides of this right now. But the other place to look at is in the fillet up here. What's happening down below. You can see some effects because this isn't square on the shaft, because it's just a hand-drawn value. But you can pretty smooth stress contours over here. That's I think adequately resolved. Probably more mesh than I need there. But so there's your comparison that you can make for one of these. And again, you make sure it's right for one of them, and then you can repeat with the other geometry. One thing that you may want, so that there's the general process there. And you can extract some of these values. One thing, if you find something you like, you can export. Let's see, what we want to do is create a figure. So I can either create a figure, create an image, and you can see that gets stored here, and then I can, for use. And if I update this, and for example, go look at, retrieve the result. At this point, I think it has just bending at this point. You see that there's no stress around that one keyhole. Then I still have that value, so I could look at different things and take those images and hold on to them. So there's your overview, and I'll follow up with a little bit more on meshing in a separate video.